Today we will read electrical resistance. So we will start with this equation. Voltage equals to current multiplied resistance. Resistance is measured in ohms, and the symbol of resistance is like this in our textbook. It's like this. But if you read engineering, you'll see that resistor looks like this. But for the time being, this is not necessary for us. We will follow our textbook one. So we better underline. We measure resistance of a component by comparing the size of the current and in that component and voltage applied across its ends. Please put it inside a box that voltage equals to current multiplied resistance. The unit of resistance is ohms, kilo ohms, mega ohms, etc. V equals to IR, V for voltage, I for current, and R for resistance. So simple math here. Before starting with simple math, I want to explain, in fact, that what is resistance. Resistance is the property of a component or a device to prevent the flow of current. To prevent the flow of current. If the resistance is high, the current cannot go through the resistor easily. And if the resistance is low in a circuit, current can flow through it easily. So high resistance circuit, current flows less, and less resistance circuits, current flows high amount of current flows. And it prevents actually the amount of charges. We will be learning all these things gradually, more and more. Let's see. There's an example here. Example 1, the voltage 12 volt applied. The doorbell is connected with 0.1 ampere of current. Calculate the resistance. V equals to IR, R equals to V by I, 12 by 0.1, 120 ohm. It's a simple finding of resistance. If the resistances, if there are two or more resistors connected in a series circuit, then total resistance we have to find out by adding them. If in a series circuit there are two or more resistors connected, then the total resistance we will find by just adding them. Total resistance is the resistance of the circuit. But this is not true for parallel circuit. In parallel circuit, finding total resistance, that is a bit different. Another example is given here. Look at this. There are two resistors and one supply voltage or battery is connected, that is 12 volts. Total resistance of this circuit, just if we add them, total resistance is 2 plus 4, 6 ohms. It would be. And what would be the current flow? Current flow, that is V equals to IR and I equals to V by R. So current is I equals to V by R, 12 divided by 6, it will be 2 ampere. Let's see. Look at this, it's 2 ampere. So current flow through this circuit is a series circuit. Current is everywhere same. Here is 2 ampere. Through this part is 2 ampere. Here it is 2 ampere. So everywhere current is 2 ampere. So what will be the voltage drop across the 4 ohm resistance or 2 ohm resistance? To find out the voltage drop across each resistance, we have to apply the formula V equals to IR. Here V equals to I means 2 multiply 4. 8 volts would be in this resistance. 8 volts voltage drop, and V equals to IR, voltage drop across this resistance would be IR. 2 multiply 2, 4 volts. And if you add 4 volts and 8 volts, would get back 12 volts. Remember, the supply voltage is equal to the voltage drop across different components in a series circuit. So I can write it here. Supply voltage is equal to the voltage drop across different components in a series. So supply voltage is equal to the voltage drop across different components in a series circuit. Voltage drop means voltage consumed by 2 ohm resistor and voltage consumed by 4 ohm resistor. Look at this 2 ohm resistor, the way that I said, find it like 4 ohm and 4 volts and 8 volts. So if we add them, we'll get back the total voltage given by the battery. All right. Now this is an experimental setup. This is a piece of wire. This piece of wire is under investigation. We want to find out the amount of current flow and the voltage. When current flow changes, voltage across this piece of wire would be changed. This is the supply voltage. This is cell or supply voltage, we can say cell supply voltage. And this is variable resistor. You can see this is variable resistor. Variable resistor, what is the function? The function is that the resistance can be changed easily. We can increase the resistance and we can decrease the resistance within a certain range. So when resistance decreased, current flow increased throughout the circuit. And when resistance increased of this resistor, resistance increased, current flow decreased. So please follow this, what I said, variable resistance. We can change the resistance of a variable resistor within a range if the resistance is high. If we kept the resistance high, current would be lower. If the resistance is lower, current would be higher. So at first we kept the maximum resistance. So there is a small current is flowing through the circuit and there is a voltage drop across the piece of wire. Ammeter is to measure the current. This is ammeter to measure the current. And this is voltmeter. You know this that voltmeter to measure the voltage. Ammeter to measure the current, and this is voltmeter to measure the voltage. And if we keep the resistance maximum value, the lowest amount of current is flowing through the circuit. And for that current will be measured by ammeter, and that voltage drop across this piece of wire would be measured by this voltmeter. And this is listed here. This is listed here. Look at this. Current is 0.1 ampere, then voltage is 0.4 volts across the piece of wire. This table is across the piece of wire. Now we decrease the resistance a bit. As we decreased the resistance a bit, current flow through the circuit increases. Current flow through the whole circuit increases. So current flow increased 0.2. It becomes 0.2 ampere. And the voltage drop across this piece of wire, it also increased. It becomes now 0.8. We again decrease the resistance of the variable resistor. Again, current flowing throughout the circuit increases, it becomes 0.3, and voltage drop across the piece of wire, it increased, it becomes 1.2. Then again another data, 0.4 ampere, voltage drop 1.6 volts, 0.5 ampere, 2 volts. Now if we plot them into a graph paper, we would get IV graph. This is called current voltage graph or IV graph for this part of the wire. Look at this. We plot this. This is the plotting on a graph paper. So I request you to do this homework. Get a graph paper and put this data on a graph paper. Get a graph paper and put this data, plot it, and draw the line. Draw the best fit straight line. It would come. Volts or voltage is also called potential difference. Voltage drop across a component. Here, voltage drop across the piece of wire. So please write voltage drop across a component or device is also called potential difference. All right. Voltage drop across a component or device is also called potential difference. And the voltage given by the cell or battery is called supply voltage. Sorry. The voltage given by a cell or a battery is called supply voltage. Right. So we came to know about electrical resistance. Now we also get introduced with IV graph. This is the IV graph of across a piece of wire. A straight line graph passing through the origin. All right. And it shows that current and voltage is proportional as a straight line graph through the origin. So it also shows that is a straight line graph origin, and so current is proportional. Voltage for a piece of wire. Remember, current and voltage is proportional for a piece of wire, not for all components. Current and voltage is proportional. Current and potential difference, you can say also, is a proportional for a piece of wire, not for all components or devices, not for all. So this is a piece of wire. This is the straight line graph. Resistance is not changing. Resistance of the component does not change. Straight line means resistance of the component does not change. Look at this. So this is a straight line graph of current and voltage. It means that throughout the graph, look at this. This is a straight line, and throughout the graph, resistance is not changing. When it is straight line graph in current voltage, if the current voltage graph is a straight line, it means that resistance is not changing throughout the graph. Please write this note. Throughout the graph, resistance is not changing. Remember it. Remember it for or lifelong. Okay, that resistance is not changing. Resistance is constant. It is straight line. Now look at this. It's a filament bulb. IV curve, IV graph for a filament bulb. It is not a straight line. It's not a straight line. Look at this graph. It is already labeled beautifully that here resistance is low and here resistance is high. So resistance changes as voltage increases, current also increases, but current does not increase as the rate of increase of current, it decreases. Very important point. The rate of increase of current becomes lower, and so resistance increases gradually. Look at it becomes horizontal line, means that current becomes constant. So at a higher resistance, current becomes constant. Resistance increases, current increment of current, or rate of increase of current, it decreases. So we can write for a filament bulb, as the voltage increases, rate of flow of current decreases. I'm not saying that current decreases, the rate of flow of current decreases. Okay, and this is the graph for a diode. Look at the graph. This is the high resistance portion of the graph. Current is not flowing at all. Look at this, there is no current. Now suddenly after 0.6 volts, current gradually increased. So a resistance allows current after a fixed value of voltage. Diode. The diode is the IV curve for a diode. The diode permits current to flow after a particular voltage applied or given. Then only just current flows and resistance becomes low. So this is the IV characteristics curve for diode. This is the IV characteristics curve for diode. Remember, IV characteristics curve for diode. This is the IV characteristics curve for filament lamp or filament bulb. This is the IV characteristics curve. This is the IV characteristics curve for a piece of wire. So variable resistors. This is the variable. Now we will read. We are here to read variable resistors. Variable resistors look like this, and the symbol is like this, and it is placed in a circuit like this. The more the resistance you increase, less the current flow. Now lower the current flow. This is the lamp. This is the cell. All right. Remember, the resistance can be changed within a particular range. It can increase. It can be decreased. This is the IV characteristics card for thermistor, and the properties of thermistor is that when temperature increases, resistance of thermistor decreases and more current flows through it. So it is used in temperature sensitive circuits. I repeat again, when temperature increases, resistance of thermistor decreases. It is used in temperature sensitive circuits. Yes.
Can you show the upper note again? I couldn't take a screenshot. Thank you, sir. Done, sir.
So this is about thermistor. When temperature increases, resistance decreases because more current flows through it. And this is the symbol of thermistor, electrical symbol of thermistor. This is the IV characteristics curve. This comes in exam, it's very important. This is the symbol. Then it comes light dependent resistor, light dependent resistor, same thing, just like thermistor. When light intensity increases, light falls on light dependent resistor or LDR, resistance decreases and more current flows. It is used in photographic exposure equipment, automatic lighting controls, burglar alarms, etc. These are some practical examples given here. I repeat once again, when light falls on a thermistor, this is or LDR, when light falls on an LDR, resistance of LDR decreases, more current flows through it. And finally, diode. Look at this. These are the symbols of diode. Current can flow through this. Current can flow this way. This way, current can flow. If diode is connected like this. But current cannot flow this way. Cannot flow this way. A diode allows current to flow only from this direction to this direction. This is positive terminal of the diode and this is the negative terminal of the diode. This is the positive terminal of the diode and this is the negative terminal of the diode. So diode permits only current flows from positive terminal to negative terminal, not like this, not like this. This is good. So remember this symbol and remember how to connect diode in a circuit. And what diode does, diode permits current to flow only in one direction. Diode is a device that permits to flow current only in one direction. That is the function of diode, and we have already seen the IV characteristics curve for diode, this one. Remember this one, in the IV characteristics curve for diode. So this is all about this electrical resistance chapter. If you read properly, you will understand all these things. Not difficult, simple things.